Hello everyone, welcome back to a new video. My name is Abhinav and today I will be talking about templates in C++. Now what is a template? Well, it is a feature of the C++ programming language that allows a function or a class to operate with any generic data type. This will allow it to work on many data types without being rewritten. Well, what this means is, normally when we write a code, we usually have many different data types that we are using. Now, in a normal circumstance, we will be utilizing many different voids, ints, floats several times in the code. With templates, you can use that once and you won't have to rewrite it every single time. It will be reused constantly. Two of his major inspirations were CLU provided parameterized modules and genetics provided by Ada. Now, there are two ways to define templates: a function template and a class template. I'll be getting to those later in the video. Now, there are some common examples for this one. One is a library container like an iterator, where we define them with different data types by passing it as a parameter, and also sorting algorithms, which have data with which we can have the data sorted in a specific order, irrespective of the data type. So, be it an int, be it a void, sorting algorithms in templates can be used properly. Now let's come up to function templates. So a function template is basically a template working with more than one data type. So we could call it an extension of a regular template. Now this is the syntax given in front of you on the screen. Over here, the class given in this place is basically to specify a generic data type. Here, a t. This is our placeholder template argument. So basically, if we're utilizing a type name like int, then we can, using a template, we can type it as template class int, what is our function, and the arguments for int, and then the body. Over here, you can notice the whole code for it. This code is what is used for a function template. Over here is where you are calling the template function, that being double to add 2.5 and 3.5. I'll be providing the links to all of these in the description below. Next we come up to our class template. This is also similar to a function template in that it works with more than one data type. One difference here is that we are utilizing a class name instead of a function name. Now it is a placeholder now the same thing. T is a placeholder template argument and class will be the keyword to specify the generic data type. Here is how a class template is operated. As you can see at the bottom, here is where my output will be. In this case, I have used the get number class to get my answer. And over here is where my numbers are: 60, 17.27, with my final answer provided here. Next comes the template overloading. Now it is a function which allows the specification of more than one function of the same name within that very same scope. Over here is an example of a function of a template overload. Here we are overloading it by displaying the class t, by using class t, and we are defining it with void display for the first function. And over here, we are overloading this function with the parameter int integer. Going down, this is what we are displaying, and here is what came out as the final answer. Now, as much as we want to ask whether there is a difference between a type name or a class keyword, there is no difference between them and they are used interchangeably in C++. But in one scenario, if it's not interchangeable and it's invalid to use type name rather than class, that being if we are declaring a template of a template parameter. This scenario can be seen in this very syntax. Now there are some advantages of using a template in C++. First off, they remove code duplication. Second, they are evaluated in real time like they are in macros. They help us to make generic callbacks. And they help us build type safe code and they are also an alternative for operator overloading. Some disadvantages are that they can make the language a bit too complicated. Some of the compilers kind of have poor support for templates. They are only detected errors when it is instantiated, and it cannot be handled correctly with older compilers. So that is all of the information I have for you on templates in C++. If you liked this video, please make sure to like, share, and subscribe. I'll see you guys next time. Bye bye and Happy New Year.